There you go. How you doing, guys? It's your soft-spoken scientist. Thank you and welcome back to my channel. So in this video, we're going to talk about solving dimensional analysis that are really rigorous problems, okay? So let's get started. The first rule in doing this is you gotta have to write the given with units. You're gonna need to multiply by conversion factors, cancel the units as you go. That way you know you're heading towards the right unit. Don't calculate until the units cancel out. And the final answer must have the correct units or else you plugged in something wrong, right? So here are the conversions you'll need to know. All of it. But the reason I gave some of them pink stars is because you don't need to memorize that. You can just know that King Henry died by drinking chocolate milk, mnemonic, kilograms, hecto, etc. I did a video on that. I highly advise you guys watch it. It's really funny and simple pimple on that. So definitely check it out. But that's not what this video is about. This video is about dimensional analysis, but I might give an example or two about the King Henry died. But as the problems advance, you're going to see, you can't entirely rely on this. It can only get you that far. So let's get started on a practice problem. I'll try two ways of doing this. So we have 3.6 times 10 to the 5th milligrams, and we want to get to kilograms is what the problem wants us to do. To get to kilograms, I need to cancel out milligrams as a unit according to my rules. So if I tried the King Henry died by drinking chocolate milk, I'm at milligrams and I want to get to kilograms. This also represents kilometers. So 1 milligram equals how many kilograms? 1, 2, 3, 4, 5, 6. But I'm heading to the left, not to the right. So it would be a negative exponent. So it'd be 10 to the negative 6. So kilograms, right? So I'm going to say 1 milligram is going to be 10 to the negative 6 kilograms. These cancel out. And when I plug this in on my calculator, I'm going to get, and take your guys' time with it when plugging it in. I know some calculators require parenthesis on the TIs, so just be careful with that. But when you multiply that all, you're going to get 0.360, right? Kilograms. You just say 0.36 if you want to be technical for sig figs. So this would be your answer. Okay. Here's another way you could do it, and this is the dimensional analysis way I'm trying to drill in your guys' heads. So if I have 3.6 times 10 to the 5th milligrams, right? Check this out. I need to get rid of milligrams. I need to cancel it out. So let's look at our rules. So, or conversions, I should say. We know that 1 gram is 1,000 milligrams, right? So let's plug that in. 1 gram is 1,000 milligrams. Great. Because I didn't say anything directly from milligram to kilogram. Other than that one example I did, but that's not in the list I gave you guys. So let's look. I also know, looking at this, let's take a look. 1 kilogram is 1,000 grams. That's awesome, right? Because look, 1,000 grams. What's in the numerator? Gets canceled out with the denominator. So 1,000 grams equals 1 kilogram. So basically you're doing 3.6 times 10 to the 5th divided by 1,000 divided by another 1,000. And you get 0.36 kilograms. And this survived. It didn't get canceled out. That's how and look at that. It matches the answer. Okay, let's try problem 2. Convert 2.75 kilometers to inches. Okay? So we have 2.75 kilometers. Always start with what you're given. I need to cancel out kilometers immediately. Well, when I look at my chart, I see that 1 kilometer is 1,000 meters, right? So they may give you a conversion list, or maybe they don't. But again, even if they didn't, you would know 1 kilometer is 1,000 meters, just because of the fact, if you really want to do King Henry died by drinking chocolate milk, you're at kilometer. You want to go to meters. B is the base for meters, for grams, for liters. 1, 2, 3. I'm going to move to the right 3 times. So that's that's 3 zeros to a 1. Right? So 1 kilometer would be what, you guys? 1,000 meters. Right. Now, I'm in meters now, but I need to get to inches. Let's take a look here. I know, I'm looking at meters. I know 1 meter is 100 centimeters. What else? That's really all I have, right? So let's look at this. We have 1 meter is 100 centimeters, but centimeters wouldn't get me to inches, would it? Let's see. I'm looking around, and I see 2.54 centimeters for every 1 inch, and I'm trying to get to inches. This could work. So let's go back up here. Kilometers canceled out. Now we got to get meters to cancel out. So we're going to say 1 meter is 100 for every 100 centimeters. Now to go from centimeters to cancel that out, I know I want to cancel that out. So automatically, I put it in the denominator because I know I need to get rid of that. I know that there's 2.54 centimeters for every 1 inch. So when I multiply all the numerators and I divide by by the denominator in my calculator, I'm gonna get 1.08 times 10 to the 5th inches, and my unit matches. Or another way you could say it is 108,268 inches. And that would be your answer. Okay? Okay, let's try this one. You got 4.50 meters squared, and you're trying to get to centimeters squared. So I'm going to write 4.50 meters squared. What do I know about meters becoming centimeters? Well, I know first and foremost, M would go here to cancel that thing out. Okay, so let me take a look at my rules. So I don't see anything about meters cubed, or meters squared, excuse me. Because remember, meters cubed is like that. Meters squared is like that. All right, so I would clear that up. So I'm looking at this and I see, let's see, look with me. You're gonna see that you'd have 100 centimeters for every 1 meter. Okay, so 1 meter is 100 centimeters. And again, if you don't have a conversion sheet, you don't want to memorize that, and you really want to do King Henry died by drinking chocolate milk real quick, you start off at the base of meters, and you're going to 100 centimeters. So look, 1, 2. So 1 meter equals 2 zeros because we moved to the right twice. So 100 centimeters. All right. So I have M with centimeters. So, but it's cubed, squared. So I'm going to square the whole thing. So now it's M2 with centimeters squared. So M2 cancels out with this M2, and I still have centimeters raised to the second, which is this. So I'm going to do 4.50 times 100 squared, and you're going to get 4.50 times 10 to the 4th centimeters squared. And the answer would be 45,000 centimeters squared. That's your answer. All right? That's how you would do that. Let's look at problem 4. Convert 0.0350 meters cubed to liters. So here we know, what do we know about meters to liters? Let's take a look. Meters to liters. Nothing that I can see. Meters to liters. Nope, nothing, right? So this is when you're gonna have to use your King Henry died by drinking chocolate milk in this scenario. So if I know, let's pull out the mnemonic. This is meters. And I have liters here. Right? So one thing that you have to know is that 1 meter cubed is 1,000 liters. I was testing you guys. You can't even find it with King Henry died by drinking chocolate milk. It may not even be given to you. Hence, memorization may be important. Just depends on what your teacher offers. 1 meter cubed is 1,000 liters. So they told me I have 0.0350 meters cubed. I know for every 1 meter cubed, I have 1,000 liters. These cancel out, these cancel out, and then I end up with 35.0 liters. Now, if you weren't allowed to use a calculator on this, just move the decimal point twice because you have 2 zeros. 3.50. Right? If it was 100, but it's 1,000. So, actually, another U-type would move it again, but if it was 100, you would just do twice. So you get 35.0 liters. Let's try this one. 1.20 grams per milliliter to kilograms per liter. So we have 1.20. And people may get confused on how to write this. You're going to put the first numerator, the first value of the numerator, grams right here, all over a milliliter. Like that. That's how you write that. So, I know what? I know I have to get rid of grams. So I'm going to put grams right there. Okay? Just kind of brainstorming. And I know I need to get rid of milliliters. Can I get rid of milliliters when it's in the denominator? No. If this is in the denominator, I know it's going to have to be in the numerator. So I'm going to put milliliter up here. Then that would cancel out. So, here's the deal. I know I need liters. I need to try and get to liters in the denominator. So liters would be down there. And I need to get to kilograms, which would be up here. And it makes sense. Milliliter with liter, kilogram with gram, right? Right? Okay. So, I know from the conversion rules, and I also know from the King Henry died by drinking chocolate milk. You could say 1 kilogram is how many grams? 1, 2, 3. So 1 kilogram is 1,000 grams. So I also know that for every 1 liter, it's 1, 2, 3, 1,000 milliliters. Which would make sense, right? Because if you have 1 liter, it takes a lot of a bunch of tiny milliliters to make that one big thing, right? It's like an atom, right? A billion cells even. A billion cells make me, and I'm one person. One person is a billion cells. 1 liter is 1,000 milliliters. So that is how you do that. You end up with the correct unit, kilogram over liters. Isn't that what we wanted? Yes, it is. So when we plug this into the calculator, we're going to get 1.20 kilograms per liter. Now, let's say your teacher said, no calculator, you guys. I don't want to, right? You can just say, okay, what's 1,000 divided by 1,000? 1. So 1.20 times 1, 1. 0.20, 1.20. Divided by 1, 1.20. So you don't even need a calculator on that. Look at that. Let's try problem 6. Convert 55.0 miles per hour to meters per second. So we got 55.0 miles per hour. I'm trying to get to meters per second. So look at this. I know hours has to get canceled out. The only way for that to happen is if hours is in the numerator. So that's something I'm going to keep in mind. I have miles in the numerator. I know it's going to have to be in the denominator. I know 1 mile is 1.609. And that's something King Henry died cannot help you with. That's something you're going to have to drill into memory. Now, miles canceled out. Good. Now we're getting there. How do I get rid of kilometers? Well, I know 1 kilometer equals how many meters? Because I know I need to get to meters. Well, I could look back at that old list. I can memorize. And if I need to do King Henry died, I see 1 kilometer equals 1, 2, 3. 1,000 meters. So, kilometers cancels out. I'm at meters per hour. That's not acceptable. I need to get to meters per second. So 1 hour has how many seconds in it? 3,600 seconds. Now, if you're just like, hey, I'll never be able to learn that, don't worry about it. So look at this. You have 1 hour, and for every hour, there is 60 minutes, right? So if you have 60 minutes, for every 1 minute, you got 60 seconds. So 1 hour, there's 3,600 seconds. Because 6 times 6 is 36. Add 2 zeros. Boom, boom, 3,600 seconds, right? So this is looking good. Hours cancels out. And then I'm at meters per second. So when I plug all of that into my calculator, I'm going to get an answer of 24.6 meters per second. Okay, let's try the next one. We have convert 725 millimeters of mercury to ATM, right? So let's start with what we have. We have 725 millimeters of mercury. I know that from the conversion list, 760 millimeters of mercury is for every 1 ATM. Millimeters of mercury cancels out. One's in the numerator, one's in the denominator. And I end up with 0.954 ATM. Let's try the next one. All right. 2.50 liters per minute needs to become meters cubed per day. Write out what you have. What do we know about this? I know from the rules, 1 meter cubed is 1,000 liters. So check this out. The liters are going to cancel out. And then I have millimeters for every minute. That's not what I want. I'm going to say, okay, I know also that for every 1 hour, there is 60 minutes. Right? So I canceled out the minutes. So I have meters cubed over hours. But I don't want hours, I want per day. But I know there's 24 hours in 1 day. So hours cancels out. Days in the denominator. Meters cubed is in the numerator. So I multiply that all and do some division. And I get 3.60 meters cubed per day. That's a bit of a doozy, but practice and it makes perfect. Let's look at this one. 0.850 kilojoules per second to joules per hour. So you have to take 0.850 kilojoules per second. What do you know about this one? Well, I know 1 kilojoule is 1,000 joules, right? So this cancels out. I'm in joules, I love that, but I need to get rid of seconds. So I'm going to say there's 3,600 seconds in an hour. Goodbye, seconds. See? Joules per hour. Joules per hour. So when I plug this all into my calculator, I'm going to get 3.06 times 10 to the 6th joules per hour. And I did it. All right, let's try this one. Convert 0.125 grams per milliliter to milligrams per liter. So let's see. Grams has to be in the denominator for it to cancel out. And I'm trying to get to milligrams. So 1 gram equals how many milligrams? Let's see with King. First of all, look at the conversion, or King Henry died by drinking chocolate milk. 1 gram to milligrams. 1, 2, 3. So 1 gram equals 1 and 3 zeros. That's 3 zeros. Milligrams. Right? So I'm going to put 1,000 up here. And then I'm looking good, right? So I'm getting there. I'm at milligrams, and I'm trying to get to liters. So liters has to be in the denominator. And I know 1 liter has 1,000 milliliters. Those cancel out. Oh, there you go. And then you're going to get 1.25 times 10 to the 5th milligrams for every liter. All right, let's try number 11. And if you have any questions about any of this, let me just be very clear. Please feel free to comment below, all right, in the video. Let's look at number 11. Convert 8.0 grams for every centimeter cubed. And we're trying to get to kilograms for every meter squared. So grams is going to go in the denominator. I know 1 gram has, let's take a look, right? 1 gram is a 1, 2, 3. 1 gram is 10 to the negative third kilograms, right? And then I can proceed and say, okay, what do I do with centimeters squared? How do I get that into meters? Well, I know that when looking at this, this is also meter, and this is centimeter. So 1, 2. So I know 1 meter is 100 centimeters. And then I just say to myself, okay, well, why don't I square this? So by squaring this, I have centimeters squared here. This is centimeters squared, it cancels out. But this is still meters squared. That too goes to both of them. So I have kilograms all over meters squared. So I want you guys to practice plugging this into your calculator. And you can pause here and see what you get. I'll give you guys a second to see. Very good. So when you plug this into your calculator, you're going to get, I wrote it. You're going to get 80 kilograms for every meter squared. This would be your final answer. And if you notice, the units work. We have m raised to the second power. We got kilograms. It works. Now, let's say you wanted to go a lot more. You wanted to. There's another way of trying this. Let's say you want to try another way. You could have done 8.0 with grams all over centimeters cubed. You could also identify 1,000 grams is 1 kilogram. You could have done that too. And you could have said, okay, 1 meter, like we did before, is 100 centimeters. Centimeters, yep. And then square that. And then you could have said, okay, centimeters cubed, grams, kilogram over M2 would get you 80 kilograms per meter squared. There's 2 ways of doing it, you know. If you guys want to start with like your 1 gram, that's fine. You want to do 1 kilogram, it doesn't matter. Either way, you get the same answer. So good job. Let's try number 12. Okay. Molecules in 2.50 milligrams of CO2. They want us to get 2 molecules. So let's start with what we got. We got 2.50 milligrams. Okay. So I know that there is 1,000 milligrams in 1 gram. I know that there's 44. They gave me this, so I know I'm going to use it. There's 44.01 grams for every 1 mole. That was invisible. But it is true. For every 44.01 grams, there is 1 mole. So, and according to the conversion list, we know 1 mole is equal to Avogadro's number. What's Avogadro's number? 6.022 times 10 to the 23rd. Goodbye moles, goodbye grams, goodbye milligrams. And I'm left with the proper unit of molecules. So when I plug this into my calculator, I get 3.42 times 10 to the 19 molecules. Write the whole word molecules out, because you don't want to get docked because you made your teacher confused and they thought you were talking about moles and not molecules. With molecules, always write the whole word out. All right. Let's try this one. Convert 3.5 times 10 to the 4th of this unit to m to raised to the 3rd. I don't even want to mispronounce that. So then they gave me this. So let's start with what we have. 3.5 times 10 to the 4th. Okay? And I'm trying to get to m raised to the 3rd. So I know 1 unit of that is equal to 10 to the negative 6 liters. And I know, because of all the practice we've been doing, 1,000 liters is 1 m raised to the 3rd. Goodbye liters, goodbye to that. And then I'm going to get 3.5 times 10 to the negative 5th m raised to the 3rd. Okay? Convert 25.0 degrees Celsius to Kelvin. I'm going to take Kelvin is equal to 273.15 plus degrees Celsius. That's the formula. So 273.15 plus 25.0 degrees Celsius is 298.15 Kelvin. That's how you do that. That's the full extreme set with setups and answers. If you want next video, we'll do hard conversions inside molarity and dilution, which is where Gen Chem exams get real. And I'm really happy you guys wrote it out with me. Please like this video. Please subscribe. I really want to be a part of your guys' journey and make a difference in any way I can. I thank you guys for watching. And no, STEM is for everybody, especially you, though.